thank you, of course, to Elastic for this opportunity. This is not our first Elastic meetup. We've actually done several of them in the US. We've done it in London, in Paris, in Tokyo, in Tel Aviv, but it's actually our first one in Singapore. It's virtual, but it still counts. So we're super excited to be here. What we're going to be talking about today, you got it, is the complexity of multilingual search. If you're here, it means you already know that search is not as simple as it seems. And if you take it to the multilingual level, it can easily become a nightmare because you want to make sure you find the information that you care about. So this will be a 35-minute presentation to deal about this, how to deal with that problem. And again, if you have questions, please use the chat, and we're more than happy to answer any questions at the end of the presentation. So before we begin, you must be wondering, who are these two lovely people talking to me tonight? So we are, well, actually we are a multilingual duet for you tonight. So we're in the multilingual theme. My name is Jeanne, and I've been with Basis Technology for about 5 years. I run the partner program in international operations from Singapore, which means I've also been working with Elastic for the past 5 years in the US, but of course now in Singapore. And I'm here with Declan, who clearly needs to update his LinkedIn profile, because this is his old title. His background is so 2018, so clearly needs to update this. But Declan is our Director of Applied Engineering. He's been with Basis for about 7-8 years now. And he has been supporting and helping our customers through their search journey. Believe me, he has seen it all. So if you have any questions, don't hesitate. I don't know, Declan, if you just want to add something about you.
Not much about me, because you've done a really good job, but just that okay. I do have a live demo at one point in the presentation, so forgive me if it all falls apart. It shouldn't, but you know how live demos go.
And as I said, we're both for a company called Basis Technology. You can see it behind me. It's not very subtle. Basis Technology is a natural language processing provider, and we've been in the search business for about 25 years now. So we know what we're talking about. And again, what we're talking about is multilingual search. And it is hard. Data is messy, and it often means it's also multilingual. And here is just a sample of questions our customers are asking themselves, maybe questions you are also asking yourselves. We're not going to address all of them, but a lot of them to help you. How do I know in which languages my documents are in? Does that mean I need an index per language, or can I have a global index? Do I need a machine translation software? Can I just translate the keywords? Please don't do that. These are just questions that you might have. And the reason multilingual search is hard and is complex is because you need a search engine to recognize and process several languages. And what I mean by process is that you cannot expect a tool to process French like it would analyze Chinese. So if you're not speaking the language, it might be easy, it might be easy to differentiate Arabic from English or from French. But if you don't speak the language, it might be harder or more hard to differentiate Portuguese from Spanish from Italian. Or for the local languages, it must be complicated to differentiate Bahasa Malay from Bahasa Indonesian, which is why you need a tool that can do this for you. So that it should identify the language and it should apply the right linguistics rules. That being said, now we're gonna look into more technically, what does that mean? What does that mean in the Elastic environment? And I'll let Declan lead with that.
Yeah, so we're going to talk about specific technical challenges around multilingual search, and talk about some of the capabilities that you might need to establish in order to actually handle those. So these are maybe what we would consider the core challenges, and I'm going to go through them at a high level briefly here, and then give you a little bit more more detail on each one before we get to some of the more exciting bits of the presentation. So you have to get the core challenges right before you can do anything more exciting or at a higher level. And we're focusing here specifically on some of the linguistic challenges. So Jeanne spoke about it earlier. You know, when you have multilingual text, you can't treat different languages as if they're one of the others. So you can't treat French as if it's English. You can't treat Japanese as if it's Chinese. You can't even treat North Korean and South Korean the same way. You can't treat your Malaysian and Indonesian the same way. So you need to understand first and foremost what language something is written in. And you know, you might think, oh, well, that's very easy. You know, they might use a different alphabet, but I'll go into a bit more detail about that. And then you need to potentially prepare the text for searching, make it searchable. And you know, we've got 4 bullet points there under language analysis. So this is taking the text, basically preparing it for search, segmenting, tokenizing, splitting and normalizing text, and then adding it to an index in a way that makes sense for when somebody comes to make a query. And I'll step through some of the specific points in that list as we go through. Then you get something a bit more exciting, the idea of understanding named entities. So these are things that are mentioned in the text, and searching for those, faceting off those, comparing them, and maybe even handling them in a cross-lingual way. So dealing with the names of people, places, organizations cross-lingually is not as straightforward as just doing a direct transliteration of the name and hoping for the best. So digging into those, what makes language identification hard? Well, there's something on the right there, a tweet, right? So social media is the ideal domain to see why this is difficult. Oh, I've got unnormal jet planes flying over now, Jen. Sorry about that. In social media, people write with short, terse language, sometimes using a lot of slang, sometimes missing out punctuation. They might even mix up the scripts or the languages that they're using within a short piece of text. That means that any algorithm that's going to try and do language identification is not going to have too much to grasp onto. So it has to be clever, and it has to have a number of different approaches to deal with the ambiguity. And also, when you have languages that are very similar, you know, you need to be able to split hairs to a degree to know, okay, does it fall one side of the line or does it fall on the other, to disambiguate. So you can't necessarily just have a rules-based model. We talk about having NLP models for language disambiguation and language ID that use the statistics, right? Leveraging the statistics, and sometimes those statistics vary on a short string compared to a long string. So it's hard, but once you've got it in place, then you can start doing other things on top. So here we're going to talk about all that prep that we might do for searching. And this particular example is completely impenetrable for me. I've got no idea where the word boundaries are in Chinese text or any Asian languages, you know, that use derived forms of any of these characters. So you can't just say every 2 characters is a word. You can't just guess at word boundaries. You need to have an algorithm that understands the structure of the language to know where the word boundaries form. Really easy in European languages using Latin and Roman script. More difficult in other languages where the words don't have formal visual boundaries between them. This is made even more difficult when some languages actually stitch words together and concatenate them to obtain a new word, right? So we talk about this idea of compound forms of words or compound words, and any search engine that's going to be able to get a handle of these needs to be able to decompound them as they're indexed and then store a form of that word to be searchable. So we talk about German, Dutch, and Korean being the kind of the poster languages for compound words. And here's just a very, very small selection of examples. One there that I can probably read and understand from my English point of view is Telefonnummer from German. If you were just to apply a naive stemming algorithm, you get something, a word that doesn't make any sense, Telefonnum, right? But if you were to do an appropriate decompounding and normalization, you'd split that out into telephone and number. So it's very important that your search indexing and the preparation of the text is aware of these word forms. You can probably understand why I, as an English speaker, haven't put up any Korean examples. I would very, very much struggle to even talk about those. I struggle to talk about the German ones. So a little bit alluded to in the previous slide was the idea of normalizing the forms. Here we can see some of the pitfalls of a naive stemming approach to normalization, because you might see that the two words that have completely different meanings might end up with the same stem. So the examples are the French, and Jen will be very disappointed in my pronunciation, as she usually is. So été meaning summer might be the same as été meaning was, which I probably pronounced them both wrong, but they each have a different normal form, right? So été meaning summer is its own lemma, it's its own normalized form, but été meaning was is actually normalized to être, which is the verb which means to be in French. Although if you were searching for summer and you got every single thing that included the verb to be or was, you would have a search problem. You'd have a false positive problem. The same with boire in the lower example in French. I love that Jeanne puts in French examples. It tests my my schoolboy French resolve that I once had.
He makes fun of my English, so I can make fun of his French.
Only about 2 words. Only about 2 words. You have a fall over. Okay, so we normalize them to avoid clashes when we do searching, and here's even more examples where stemming can cause some funny some funny normalizations, and where lemmatization would give you a more appropriate normal form that you would store in your search index. And the one that I like to pick up on is okay, let's look at the word several. If you were to stem that, you just chop the tail off, you're left with the word sever, appropriate when I'm talking about chopping. But really the lemma there, the actual normal form of several is several. And then the same with organization. So if you were to apply naive stemming on that, you would have the word organ, whereas we understand that the real normal form of that is organization. So we shouldn't really do anything to those words. But you might be searching for several organizations, and you might get back results that talk about severed organs, which is not really an appropriate search response. So I think that's quite a neat example in the text. So yeah, you get clashes where things have the same stem, and then you get poor results if you have a bad stem. So yeah, using a smarter form of lemmatization for the normalization of your terms is going to work better. Sorry, John, I'm taking too long on these. Okay, the more exciting part is when we look at content and we try and get a better reading and understanding of that in a way that a human would, which is pulling out the features, extracting the things. Here's a piece of text. There's a mention of a person, and we can all read that, generally with the English grammar that we understand, that Elon Musk is the name of a person. And then he's building first sustainable city on Mars. It'll take 1,000 starships in 20 years, which is pretty grand. If you're going to be doing named entity recognition, especially in a multilingual case, what you can't necessarily do is have an exhaustive list of all of the things you might be looking for. This is an old-fashioned way of doing it. Elon Musk is not a common name. So it's highly unlikely that if you were writing a list of names, that would be one that you would include. Even if you'd stemmed Elon Musk, you might get even worse results, to say the least. So we understand that we want to have an engine that can read and understand it like a person, use contextual clues and grammar to understand based on the position and the context that is the person's name. And then Mars, we can all work it out that it's a place. But after you've extracted something, you might want to use it as a facet, but you might also want to be able to get a disambiguated resolution of that thing, because what you don't want to do is get confused between Mars, the city, and Mars, the chocolate bar, in the same way that you don't want to get confused between the Paris Hilton Hotel and Paris Hilton, the former celebrity. There's all of these clashes between entities that you need to be quite smart about. And doing the extraction is one part, but doing the resolution is the next part. It gets even more confusing when you're trying to then match an entity. So you might want to match the name of a place, match the name of an organization, match the name of a person, and then handle all the variations of those. So you might use context to help, but you might want to use the linguistics to help as well. And then sometimes you're even drawn into having to take advantage of the semantics, the meaning, to do that match. So we've got the Tsingtao brewery example in the bottom. We need to be able to match beer against brewery to some degree without having an exhaustive list of translations included in there. Jean's later going to give an example of doing name matching and trying to do a smarter job with name matching. Okay, so I went through some of the things you would do to prepare text for making it searchable, some of the pitfalls and challenges that are in there, and then some of the more higher level, more exciting ideas that we're going to expand a bit upon later. But ideally, you know, upfront, you want to get very accurate with your language identification, and then you want to be able to properly analyze the text that comes in to prepare it for search. So the normalization aspects, you know, maybe doing lemmatization rather than doing stemming, doing decompounding rather than stemming a word before you've decompounded it. Then on top of that, you're going to layer entities, and entities are going to help you with faceted search when you're looking for things or documents that include mentions of things. And then you could use semantics to help you match the things like beer versus brewery. But I'm going to expand upon semantic search and leveraging the meaning of terms in a demo example as well. So this these links can be made available, but there's a whole bunch of blog entries and links on the Elastic websites that help you understand, you know, where you might get started with using languages, because Elasticsearch allows you to apply different language analyzers for the tokenization and the normalization as you index. You know, so reducing word to the root form, that's all about the normalization, and then how you would do a workflow. So you develop potentially a pipeline for text indexing where you would do language identification up front with Elastic. So there's resources out there, and we can help point you in the right direction, or you can start perusing Elastic's content yourself, or even looking at the blog entries that we provide on our website too. Okay, Jeanne, I'm going to pass over to you now. I probably jumped too far. I'm going to stop my share.
And I'm going to start mine.
It's going to go really smoothly.
Yeah, no pressure. And now you should be able to see it.
Seamless.
Perfect. So now that we've talked about the underlying, technologies that you need when it comes to search, and now that you understand the importance of the building blocks, the foundations of having the right tools in your search engine, we're going to be talking about what is the impact for your business, and why is it important that you have the right tool when finding things or finding people are critical to your business. So for that, we're going to be using a real life example. Société Générale, big French bank, one of our customers, who have been trying to tackle the $1 billion problem. And you probably think I'm exaggerating when I say $1 billion, but I'm actually not. Google it. You can look at the number of banks who got fined for not complying or because of employee misconduct. And then look at the amount these fines are. It's a huge problem. So like many banks, Société Générale was overwhelmed by the number of false positives produced by their internal monitoring technology. They were dealing with 10,000 alerts a day, and the majority of these alerts were false positive. This is brutal. Their current internal affairs system was generating between 10,000 to 20,000 alerts a day, and the majority was wrong. So this information overload was exposing them to employee misconduct risk and regulatory penalties. What they wanted to do to be able to detect and identify employee misconduct and internal fraud was to analyze and process internal communication, that being internal reports and documents. It is messages, WhatsApp text messages, emails, but also call transcripts, which means they needed to process formal documents, formal writing, but also conversational writing. And on top of that, they're a French bank, but that doesn't mean all their communications in French, right? They have offices all around the world, they have customers all around the world, and they needed to do all that in 40+ languages. So because of the amount of false positives they were getting and the amounts of alerts they were getting, they decided to rebuild completely their internal investigation system. They committed and spared no expense in going for a fully modern AI NLP driven communication monitoring platform that was able to scan all their communication, audio and textual, and all that to find criminal activity. And it worked. They brought in the right technologies, and they went from 10,000 alerts a day to 100 alerts a day. And we went to a majority of false positive to a majority of true positive. This was my wow effect. This is my wow slide. I can't see your faces, but I expect you to be making that face right now. And you must be wondering, how did they do that? And we'll talk about it. But the other opportunity or the other benefit for them that it brought is that now from these 100 alerts that they had a day, they were able to dig into it. They were able to look into the ones that were posing or that represented a risk. And they went from zero investigation to 2 and 3 a week. Major benefit for them then, just by getting the right tools. So what made the difference for them? They went for best of breed technologies. They wanted a holistic platform. They wanted all the tools to interconnect. They chose Elastic for a scalable search infrastructure. And Rosette, which is Space's technology tool, and Rosette's plugin for the multilingual text analytics part. And the fireworks that you see here, it's because this deployment is one of the biggest, if not the biggest, Elastic deployment in the world. We're talking 150 servers, which with each of them with 6 Elastic nodes. This is a huge deployment. Now that we've talked about how important it is for your business to find the right things, to process the right text, we want to emphasize the fact that it's not the same when it comes to looking for names and identifying names. It's a very specific problem, and this is why. There are different levels of sophistication when it comes to name matching. And the one you're going to choose depends on how critical and essential it is for your business to identify the right people. So here, the problem with names first is that they become in a wide variety, of course. They're ambiguous. There are no right or wrong when it comes to transliterating or translating a name. And I know what I'm talking about because my name, Jeanne, which is a classic French name, I've seen it translated 4 different ways in English. It could be Joan, it could be Jane, it could be Jean, and it could be Ginny. I have a preference, but I've seen all of them. So now you have the option to either store the one you like in your index, but if I choose another one, you're gonna miss it. Store all of them, the 4 options, and that means you're gonna be using a lot of compute resources. Or maybe there's a 5th one out there that I don't know about, which means if you need to match my names with the way you've stored it in your index, you might be missing it. And unfortunately, I'm using a sad example to show how bad this could go with the Boston Marathon bombing example. So just to make it very short, the Russian intelligence services had given the name of the Tsarnaev brothers who committed the bombing to the FBI, to the US intelligence. But the thing is that they used the real name in Cyrillic script, and the US intelligence needed to put it in Latin script. I've had that question before. So Latin script is the Roman alphabet, so it's the one you can actually read here. So the way they did that, they translated the name, they stored it under Tamerlan Tsarnaev with the Y, but on the ID that he showed, the Latin name that he had Tsarnaev without a Y. So the border agent did his work. He took the passport, scanned it, looked if that person was in a screening list, but 1 letter difference, and the system did not match it. So they let that person in the country when that person should have been stopped at the border. And this is because they were using a rules-based model that can be fine if it's not critical to your business. but it's definitely limited if you need to make critical decisions. So if you go one layer of sophistication up, and we're talking about machine learning models, we'll see that it can understand different variations of the name. It can understand phonetics, it can understand cross-language, it can understand different scripts, titles, nicknames. Let's say you've stored the person's name as Robert in your index, but they present themselves as Bob or William and Bill. This is something that a model, machine learning-based model will be able to spot. It'll be able to understand if the tokens, which means the part of the names, are in a different order. This is not an issue. And it will analyze each token. So in that case, if you take the Tamerlan Tsarnaev example, they would have matched it. It doesn't mean the Boston Marathon bombing would have been prevented. It just means they might have found an obstacle on the way. And that's definitely something very important. And also another problem with names is when you use edit distance models, you also increase the amount of false positives. So the chances of you finding the right name are also being reduced. But then we've talked about cross-script, and it can be even more complicated. If you take Arnold Schwarzenegger's example, his last name is complicated, and there are different ways you can mess up his last name even in Latin script. Now, let's say you've stored his name in traditional Chinese or in simplified Chinese. You want to be able to match all these different variations of the same person, of the same name. So to conclude that part, it's really to find names, it's a different process, and you need to have the right sophisticated tools to do that. Now, that being said, we've talked about things, we've talked about people. What's the future of search? Declan, can you tell me what is the next gen search tools that people should be looking forward to?
You put me on the spot there, Jen, but I'll try my best. One thing just to add about that name matching example that you gave for the Boston Marathon bombing is that now, several years later, 5.5, 6 years later, the system that does the name matching at the border is a combination of Elasticsearch and our smart name matching algorithm from Rosette. So no longer will that actually happen, right? So just to add a little bit on that story. And
I'll stop sharing so you can,
I'll take the screen back, and hopefully it'll be completely seamless again, right? Oh, hang on. I've got to
seamless. Seamless.
Oh, blimey, everything's disappearing. Where's my Zoom gone? Talk amongst yourselves. No, don't talk amongst yourselves. Zoom.
And again, if you have questions, don't hesitate. You can use the chat, whether it's more about the morphological analysis tools that we've talked, or models that we've talked at the beginning. If you want to talk about names or any other subject related to multilingual search, please don't hesitate.
Oh, I know what I've done now. I accidentally minimized my Zoom option. All right, it's fine. Thanks. We're good. We're good. Share my screen. Maximize that. Seamless. So yeah, the next exciting thing we want to talk about is semantic search. So I spoke very, very briefly about this. The idea, can I look at the foreign script version of Tsingtao Brewery and match it to a Latin script version? And can I leverage the meaning of the terms to help me do that without doing a direct translation? And how do you put this even in a search context? How do you take the meaning of something and potentially write it in a numerical form that you can leverage? So this is something that's a real R&D focus for a lot of software companies, a lot of NLP companies. It's something we've taken a great interest in. There's open source efforts out there, and there's even capability built into Elasticsearch to help you use this in a search. So what I'm really talking about is taking a word or a set of words, reducing them to what we would call a text vector by a process called text embedding. And what do I mean by embedding? What we're doing is that we're creating a big big space, an imaginary space with multiple dimensions, and then we're putting each word at a different coordinate in that space and noting down what that coordinate is. When you've got that matching space, it means that you can actually understand how close something is to something else. And here in my, my slide, we have a very much simplified view where we're looking at like a pretend two-dimensional version of this. And you'll see I've got 3 different clusters of pieces of text. Maybe the simple one to talk about is the blue examples on the left-hand side. And I've got the name of 2 companies, both of them called Eagle, but one is Pharmaceuticals Inc. and one is Drugs Co. And if I was to be understanding why those are close to each other, it's because actually the meaning of the term pharmaceuticals is not too far away from the meaning of the term drugs. And a model that leverages this, this matching space, these text embeddings and these text vectors would be able to say, I can see where that one is positioned and I can see where that one is positioned. I can measure the 2 and I can look at either what, the overlap or the similarity score. On the right-hand side, it gets a bit more complicated because potentially within this matching space, you could have terms in different languages as well. And if you're going to be doing cross-lingual search with semantics, you want to make sure that all of your matching spaces actually align with each other. So I've got those terms in English there, machine learning and AI, but I also have counterparts in Chinese and Hebrew there as well. The same goes for Tesla in red, and then energy storage at the bottom. So putting things in a matching space, giving them a coordinate that you can compare against, potentially allows you to map out a space and understand where things are similar to each other. And I've been given the job of actually trying to demonstrate this capability for you. So this is another seamless switch over, and I really, really hope that my demo doesn't crash while I'm sharing it. So why does this help in search? Well, there's 2 ways that it's going to help you in search. One is that you can do query expansions that you'd never thought of doing before. So, we talked about doing a linguistic query expansion potentially earlier when we talked about normalizing text before it goes into an index. Here we're going, several steps further. So I can give you a potential query term, and what I want to see back are expanded terms that are associated with it based on the semantic similarity. So let me start by just doing it in English because I'm very, very comfortable in doing that. I'm going to put in a search term, and then I'm going to look at what expansion terms I might also be able to leverage in a search. So my simple example was earthquake. So what are the words that are similar to earthquake that I could use in an expanded query? First of all, starting with just English. I hit the button, he says. Did I hit the button? This is where, there we go, right. I hit the button and now I've got a visualization with some new terms that have been provided to me. Words like tremor, aftershock, tsunami, mudslide. Right? So these are associated terms semantically with earthquake. They're similar in that they're positioned closely in the semantic matching space that we've created. These words are, depending on how close they are, is what size they are as well. So the words quake, temblor, they're close. But what's neat about this is that if I have my semantic spaces overlaid, I can do the same thing, but I can add in the terms in Spanish, or I can add in the terms in Chinese that might be associated with my initial term earthquake. So now I've not just got a keyword expansion, I've got a multilingual semantic keyword expansion. And I'm always a little bit surprised when I see that. One of the ones that's kind of funny that I like to show, the guy who developed this formerly worked for an intelligence agency. He now works for Basis with us. So the ongoing joke is that if we use the term spy, maybe we uncover something that we didn't know before. But now, I use the word spy and I look across the English, Chinese, and Spanish. I wouldn't necessarily know that some of these words in Spanish were related, and definitely not the Chinese. But you get terms like CIA, KGB, Mossad that get included in the similar terms that you might be searching with, and they're directly relevant, right? So it makes a bit of sense. So now that's using semantics for keyword expansion, and I'm going to talk about maybe just using semantic search straight up and looking at it in a cross-lingual sense as well. So I'm going to kill this, this view, and I'm going to jump over to my other one, which I don't have enough space for. There we go. Okay, so although this isn't a pretty UI, it's going to help me do a search demo. What I've got in here is some pre-indexed data, and it's just some news data. And sorry, everybody, it's just all in English and Latin, but I'll see what I can do about doing some cross-lingual queries. So this is just news data, a whole different set of topics in here. But what I want to do is find things that are relevant to a search term. Makes quite a bit of sense. But instead of using the keywords and finding the words that are in the text, I'm just going to leverage the semantics instead. So I'm going to come in and, you know, we talked about Eagle Pharmaceuticals, Eagle Drugs Co. earlier. So if I search for the term pharmaceutical companies, I'm going to see if there's anything that's semantically related in this. So what it's doing is it's reducing this term to a set of numbers, you know, what we call a text vector, and then it's comparing the text vectors against the stuff that I've pre-indexed. And you know, Elastic provides places to add that metadata in. So I hit the button, right. Straight away, I get a little bit of highlighting, showing me different colors, what's more similar, and then I can look at what is the topmost result. And oh yeah, by the way, I did some preparation on this text. So I've actually split it by sentence and paragraph and file. But you know, I search for pharmaceutical companies, and my topmost result in green is this here. I scroll down and have a look at it. And actually, this is a sentence that came out of the news talking about drug companies, and it mentions Merck and Pfizer. So these are obviously big drug companies, and it talks about one of the stories involving their products. So searching for pharmaceuticals, I've returned some relevant results that don't explicitly mention the term pharmaceutical. That's exactly what I was trying to do, and that's the power of this. Going the same way, you know, I can search for the term airport, right? So I might have some news here about airlines, aircraft, aviation, etc. And you know, it's going to be a different set. So my topmost result now is talking not about an airport or the word airport specifically, but talking about an airline that has scheduled flights and a number of aircraft. So it doesn't explicitly include the term airport, but does have a direct relevance and correlation with what I've searched for. And by the way, I can do the same kind of thing in here. Instead of putting in Latin, I can search with Chinese text. So any of the languages that are supported, that exist in this semantic space. So this may or may not be an accurate translation of drug companies into Chinese, but at least the semantics might still be included in there. So if I run this, I can do exactly the same search that I did previously. I get exactly the same result that I got previously, talking about Merck and Pfizer being drug companies, but now I've searched with Chinese instead of English. And I haven't done an explicit translation. All I've done is leverage the semantic vectors that exist underneath it. And you know, the same deal holds up on the airport example. And so I can come in and search with what may or may not be an accurate translation of the term airport. And once again, I can get, you know, the relevant results for, you know, this jet company and, you know, sentences that describe it. So even though I'm not doing translation, I can leverage the meaning cross-lingually in a search context. All right. You may also be a little bit curious about what I'm showing down here. This is actually my distribution of results, and distribution of results above a certain score. Even if I hover over the line, I can actually see which document, which sentence was actually relevant at each one. But it helps me see that I'm not getting a huge number of false positives. Actually, you know, maybe only the first, you know, the first 10 documents there are actually of any relevance at all. It's not showing that there's every document returned, but just a certain number of them above a certain threshold. And that helps me decide where the cutoff might be if I was doing a search relevancy and you know, returning a set to an end user. Okay, so that's what I wanted to demo to you, and that's doing cross-lingual semantic search. All right, and now I'm going to jump back to the slides. And I think it's you, Jen, isn't it?
Yeah, and we're actually right on time. This is the conclusion slide to emphasize the fact that first, you can't search the same way on structured text and unstructured, because In Unstructured, your tool is, again, needs to be capable to understand where the words are, what they are, and to understand the context. And my transition would be, we're not back. We're here right now to answer your questions. So if you have any questions, please don't hesitate. And if some questions come to your mind after this presentation, you can always send us an email. Declan can show you the next slide with our email. So please don't hesitate. I actually saw that there was already a question. And there are a few questions. I don't know, Declan, I'll read it to you because the first one is for you. How do you normalize names or cluster them, build features around them, and ideate to a single person? For example, in a research paper, different journals have different conventions with various permutations like Rahul K. Sharma or R.K. Sharma, Rahul Kumar Sharma, etc. How do we normalize and cluster them?
So it's a really hard problem, right? And names, as you rightly point out, there are a whole set of phenomena that could be introduced. So titles, initialisms, order of names, and then misspellings, phonetics, concatenations, language translations, transliterations, and things that go along with it. So you ideally need an algorithm that can handle all of those, and then something that can efficiently process them when it comes to searching and matching. What we actually have is a patented two-part approach to doing name matching, where we would we'd generate a set of keys for every name, multiple keys. So not just one, not just a soundex key, not just a metaphone key, not just an initialism key, not just any other handful of normalizations, but a whole set of keys that represent a name that allows you to potentially shortlist a set of matches. And then you would want to have a direct linguistic model that would understand both the sounds, the conventions, and the semantics of a name when it comes to ranking, rescoring, and returning them to the user. So we've done previous Meetup talks where we talk almost explicitly about name matching as a search problem. We've got resources around that that we're happy to share. There's actually a nice treatment of it on the Rosette.com website as well. So if you want to know more, reach out. We can send you links, or we could have a follow-up call.
Great, thank you. And there's another question which is more for Elastic. So what's the preferred approach to build and store multi-languages data in Elastic? Different index for each language, or use the same index with different fields? Use multi-field feature of Elastic, or any other approach? Could you please explain the differences in relevance and performance?
So it's another difficult problem, right? So I'll give the example of Société Générale that we talked about earlier. So where they are actually indexing multilingual text, huge volumes. And the approach that they chose to take was to index into separate fields. So in their index, they had a schema, and so a document would contain a field for every potential language that could be indexed, and then there would be a different analyzer switched on for each of those fields. And they may actually index the content into more than one of those fields if the language identification was ambiguous, but that tended to be the way of doing it. So rather than doing split indices, you'd keep it all in the same index, but just within the schema and within a document have more than one field with a different analyzer on it. And that tends to be the recommendation we give, but it is always dependent on the content and the problem and the metrics that you require around indexing and query performance. So there might not necessarily be a catch-all answer, but that's one that we see quite often. Any more for any more? Very good.
I don't see any more coming in right now. Ning, I don't know if the answer Declan gave is good, or if one of your colleagues wants to jump in and give his view on it, or if we're good.
I think we're good.
Okay.
Yeah, we were listening to Declan.
Perfect. Well, I'm good. The answer was good then. We're just giving people another minute or two maybe to type in their questions. again, whether it's on NLP in general, Elastic, Rosette, don't hesitate, we're here. But again, if you want to reach out to us separately, here you have our email addresses. You saw our LinkedIn profile at the beginning, so we're more than happy to have you connect with us and to get the conversation going.
Yeah, and we're doing plenty of these calls at the moment, aren't we, Jen? You know, there's
yeah.
everybody's available at the moment. We're all in our home offices, so yeah, easily called.
And actually, that's a good point, Declan. If people are interested, we're also hosting a webinar on Tuesday about AI for fraud, more specifically, I believe.
Yeah, it's financial crime problems, right? So.
Exactly. Yeah. So if you're interested in that, ping us and we can send you the invite. So there's another question. Declan, when you show the similar words in different languages, why haven't the direct translations been shown as large as the original search input?
So that's an interesting question, right? So they all are. All of these, there's all subtlety around this stuff. So when we create the semantic vector space in one language and then create one in another language and try and overlay them, what we try and do is find some anchor points that help us orientate the space and then normalize the numbers, right? But that doesn't mean that every direct translation is gonna be perfectly overlaid in the semantic matching space. Some of them will be, but other ones won't be. And some of this is due to the subtlety of language, because you know, there might be some other semantic connotations of a certain word that would skew where it would be positioned. You know, I think, you know, you can't ever necessarily get a perfect translation between two languages because of that problem, especially when it comes to you know, handling things that are culturally specific. But yeah, also it just comes down to the mechanism whereby we try and overlay these things. But you know, it's something that people try and leverage for translation, but it's not ideal for that. But it's good for this kind of fuzzy search expansion where you can't necessarily handle or you know, the perfect set of terms in the first place. I know that's a bit of a fluffy answer, but it's kind of the state of the technology as it stands. Yeah, and maybe if you did have a perfect translation in terms of the overlay, then you would miss some of the subtlety that's involved in semantics.
Yeah, and that's actually a great transition to the next question, which is, can you define what semantic search is? Or you might have heard semantic similarity as well, but Declan, do you want to give it a shot?
Yeah, well, in the simplest terms, it's leveraging the meaning of a word or set of words to help find things with a similar meaning. So yeah, we talk about linguistics, and that looks at structure and syntax and words, and you know, how those words are written based on the you know, the letters and characters that are in them. That's not semantics. Semantics is about the meaning. It's what makes pharmaceuticals and drugs related, where those words look very, very different from each other. Okay.
Yeah, I hope that answers the question. Again, leaving some time for people to write a question if they have more questions. But thank you very much for the questions. They're all great. It's too bad we can't see if people are typing. Zoom doesn't tell you if the person is writing a question or not. So I don't know if there are more coming in. It's 49. We'll give you.
Well, Jen, as you said, you know, we've got plenty of ways to be reached as well, and
oh, yeah.
we're not going anywhere, right? So it's all good.
I don't see any more questions coming in, so I think that might be it. We're right on time. 35, like 40-minute presentation, 10-minute Q&A. Perfect.
It's like we really practiced it. Then it's really,
yeah,
okay.
and we did. And so Ning, we'll let you take over since there are no more questions.
Thank you so much. I'm just gonna share my screen again. So just want to let everyone know that there will be a recording and it will be sent to the email address that you use to register for this event. You can also actually find the recordings uploaded to our YouTube playlist. Just a quick search on Elastic Meetup's YouTube playlist and you should be able to see all of our past meetups. And that's all. So thank you so much, everyone, for staying till the end. And it was a great presentation, Jin and Declan. I really enjoyed it.
Thank you. We try to make it as dynamic as possible.
Yeah,
Thank
it was
you
great.
everyone for joining.
Thank you.
Thank you. Bye.
Okay, thank you very much,
Bye.
everybody.